ito pala yung naalala ko na. May in-upload ako sa Canvas na Excel file, no? If you go to Canvas, login lang ako. So if you go to Canvas, dun sa ating discussions tab, no? Punta tayong discussions. May makita kayo na dinagdag akong bagong file. Okay. So I added a new file which is named Titration Curves. So itong file na to, it contains some examples that has na kinumpute ko yung mga pH when certain volumes of titrant ang inad. Okay? So ganyan ginawa ko, in Excel ko talaga yan, no? So ito yung volume molarity analyte, volume analyte, molarity titrant, volume titrant, no? And then at the same time, green off ko siya sa kabila, no? So I hope you can use this now when reviewing for the titration calculation. Naglagay ako dito ng SASB, SBSA, WASB, and WBSA, no? So yun yung mga nilagay ko dito sa Excel. Okay, download nyo na lang and practice kayo mag-solve gamit yon. Okay, makikita nyo naman sa equation kung ano yung ginamit ko eh. Ayan na. Kunwari ito, Henderson-Hasselbach Equation, pag tinype mo sa Excel. Okay, and yan, graph ko siya sa gilid na. So nakikita nyo yung mga characteristic ng graph, no? The inflection point, the buffer region, no? Ayan. And nilagay ko rin yung first derivative, although again, this is not the focus of our study. Hindi naman tayo BS Chem, pero nilagay ko pa rin, no? Just to prove my point na itong inflection point, mataas yung slope, no? Which is true according to the first derivative of the graph. Okay? Ibig sabihin nun, kung nasaan yung highest slope, andun yung inflection point and the end point. Okay? And yan, using calculus, legit na ito nga yung mataas yung slope. Okay? So yun, hindi nyo naman kailangan gawin yung first derivative. Okay. Kung gusto ko mag-focus kayo dito sa pH calculation, tinype ko dyan yung equations. Pwede nyo gawin dito is to manually solve for them. Then tignan nyo kung tama yung sagot nyo sa nakalagay dito. Okay. So ganun din for WBSA. Ayan. So yan, ito yung inflection point ulit. But since the slope is negative yung ating first derivative. Okay? So yan. Hopefully magamit nyo ito sa review nyo. Mag-upload pa ako ng mga worksheets by the weekend. Okay? With answers. And yan. Yun lang. Okay? So with that, we can now proceed to our discussion. Let me open the PowerPoint. So last time may iniwan akong assignment sa inyo. And hopefully nakuha niyo itong mga sagot na to. Hanapin ko lang yung slide na yon. Okay, so ito. Okay, so this is the answers. These are the answers for the items we left last time. No? Ayan, ang dami nating iniwan and ito yung sagot sa kanila. And hopefully you were able to come up with this solution. Okay, so yun yung mga sagot. And if you graph it, the curve must look like this. Although pangit yung pagka-drawing ko. The idea is, ayun, andito yung inflection point. Okay, and at the same time, andun yung end point or the equivalence point. Okay? So sana ito nakuha niyo yung sagot. Kasi pag hindi, there's something wrong sa equation niyo. Okay? Okay, ayan. So let's proceed with the next type of titration, which is on weak acid strong base titration. Again, kung sino yung nauna, siya yung analyte. Kung sino yung nahuli, siya yung titrant. No? So for weak acid strong base titration, so that means our analyte is the weak acid. No? Okay. So suppose the weak acid is HA. Okay. So yan. So HA yung ating weak acid in this case. Okay. What we know about weak acid is that yung kanyang dissociation ay partial lang. Okay? So, may apat pa rin tayong stages. Okay? So, may apat tayong stages for the titration of Wasb. And then, these are the species present, and then the corresponding equation are shown here. Let's explain why the equation looks like this. Okay? Explain natin. Kasi syempre, hindi dapat tayo satisfied sa, sundin nyo na lang to. Hindi ganun. College tayo. Kaya kailangan marami tayong questions. Kunwari, bakit ganyan? Okay. Let's ask ourselves, bakit ganito yung equation dito sa initial? Okay. So, ang sagot doon ay dahil sa species present. Okay. So, let's start na talaga. So, initially, in your Erlenmeyer flask, since your weak acid is the analyte, that means yung weak acid lang and yung water yung present sa solution sa Erlenmeyer flask initially, di ba? Okay. Of the two species which will contribute to the pH of the solution, the weak acid. Malamang weak acid, no? Acid yan eh. Ito, tubig lang yan eh. Okay? So, of the two species, ang weak acid ang magko-contribute sa pH ng solution. And we know that weak acids, ito ay may partial dissociation. Ibig sabihin, only few amounts of it will dissociate. No? And that can be described by an equilibrium equation, HA, dissociating into H plus and A minus, the conjugate base. So you can see, we are producing H plus. Zoom in ako dito. So you can see we are producing H plus. That means this equation is governed by the Ka equation or the acid dissociation equation or acid dissociation constant. Okay? Basta may nakita kayong H plus sa product, Ka yon. Okay? And how do we write the Ka for this equation? We write it as Ka equals product over reactant. Diba? Okay, if you apply the ice-table concept, we can rewrite this as x squared divided by the concentration of A minus x. No? And then applying the small x approximation, we say that this one is negligible provided that the ratio of CHA over Ka is greater than 1000. So that means the equation can be reduced to this, so there will be no need for quadratic equation. And then eventually, we can simplify this as square root of Chaka. So that is how we arrive with this equation. X equals square root of Chaka or H plus equals square root of Chaka. Naaalala na. Okay? So yun. Ayan. Okay? Yan, yun. Then, kunin mo na lang negative log niyan. You have your pH. Okay? Gets na tayo dito, ha? Pag may question, itanong. Okay? Next stage, pre-equivalence point. Pag sinabing pre-equivalence point, hindi pa tayo tapos, no? Hindi pa tayo tapos sa reaction. That means, we are adding titrant, pero hindi siya enough to completely neutralize the acid. Okay? So, ibig sabihin, in our solution, we now have the following species. No? We have the water, again. Andyan talaga yan. Pag walang tubig yan, edi paano matutunaw yung chemicals? Sir, kailan po uli pwedeng ma-neglect yung X? No? We can only neglect X, no? If you could still remember, yung Cha over Ka is greater than or equal to 1000. If this is the condition, then you can neglect the small x and then you can use the square root of Chaka. Okay? Naalala na? Oh, okay. So, yan. Yung ratio ng Cha pati ng Ka, kailangan greater than 1000. Okay? So, yan. Pero again, for simplification, para mas madali ang usapan, ito na lang talaga gagamitin natin. Okay, ito na yung gagamitin natin regardless kung masunod to or not. Okay? Okay. Kasi kawawa naman kayo kapag nag-ano pa kayo, nag-quadratic pa kayo, no? Mamaya umiyak pa kayo dyan eh. Okay, para ano, parang mas madali, edi ganito na lang. Okay, square root of tsaka. Okay, para easier yung life natin. Okay. Nagamit ko naman to nung boards, pumasa naman ako, mataas naman score ko doon. Kaya, ibig sabihin, pwede ko to gamitin talaga. Okay? Basta ang alam nyo, dito yung galing sa equilibrium. Okay? Balik tayo. Pre-equivalence point, we are adding titrant, pero hindi siya sapat to completely neutralize the acid. That means, we have the following mixture. No? We have the water, we have the acid, which is lesser than the original, and now, the presence of the conjugate base. No? If our solution has a mixture of a conjugate base and an acid, that means we have a buffer equation. And the buffer equation is known as the Henderson-Hasselbach Equation. Ano meron sa buffer solutions natin? Pag sinabi natin buffer solutions, these are solution that resist pH changes, no? Because of the balance between the two. And the Henderson-Hasselbach equation looks like this. pH equals pKa plus log conjugate base over the acid. The remaining acid. Again, emphasize ko, remaining acid. Kasi nabawasan na yung acid mo eh. Nagdagdag ka na ng titrant. Okay? So that's the conjugate base over the remaining acid. Kaya nilagay ko doon, less. Okay? Saan nanggaling tong Henderson-Hasselbach equation? If you could still remember our discussion, itong equation na to, ni-negative log ko both sides, then inire-rewrite ko, then arrive with it, and then nag-arrive ako sa equation na to. Okay? So instead of you doing that process, sundin na lang natin to. Kasi alam naman natin saan to galing. Dito lang yan, sa Ka. Okay? Dito yung galing eh. Zoom in tayo. Now, alam ko yung equation na gagamitin ko. But what are the values of Ka, A, and the HA? Okay? Ano yung values nila? Ano yung pa-plug in ko? Kasi it is not enough na alam mo yung equation. Kailangan alam mo kung ano yung ilalagay mo doon, di ba? Ano yung isosolve mo to get those values. Okay? So, let's start with the pKa. Remember, pag may P sa harap, ibig sabihin nun negative log. Okay? So, this is just the negative log of Ka. The Ka will be given. If not, nasa table yon that I gave you last time. Nasa chapter 4. Okay? Nandun yan. Magdadagdag pa ako ng Ka values sa additional worksheet natin. Okay? Magdadagdag pa ako doon ng Ka values for your reference. Ayan, a negative log lang yan ha. About this one. Numerator, denominator. In the numerator, you have the conjugate base. On the denominator, you have the remaining acid. Okay? Kung mapapansin nyo, ang nilagay ko dito, square bracket. No? Square bracket kasi concentration yan. But, ganito. Are they in the same solution? The answer is yes. No? Para silang nasa iisang solution. Ibig sabihin nun, iisa yung volume nila. Remember, pag molarity, that's mole over volume. Ganun din sa baba, mole over volume. Since they have the same volume, then we can simplify this as the mole of the conjugate base over the mole of the remaining acid. Okay? Parehas silang nasa iisang container, kaya we can cancel out the volumes. Gets tayo doon. Okay? Pwede mo i-cancel out. So that means, instead of finding for the concentration, we will just find for the moles. Okay? Ngayon, how do we get the moles of the two? Dito muna tayo sa denominator, HA. Ang sabi ko, ang HA ng acid nababawasan. Why? We are adding titrant to our solution. And remember, sabi ko last time, when you add base to the acid amount decreases. Kasi some of it are being neutralized, di ba? So, ganun din dito. That means for us to know how much acid is left, that is the mole acid minus mole of the base added. And what is the acid? Acid is the analyte. So I can write this as MAVA. Molarity, analyte, volume, analyte. Ayun, pag multiply mo lang sila. Gets tayo doon? Bakit A? Kasi ang acid, yun yung analyte. Okay? How about the base? The base is the titrant. So this is MTVT. Gets natin yan? Okay? Sana gets na. So ibig sabihin, the mole of the acid remaining is MAVA minus MTVT. That is the mole of the acid remaining. Kasi ito yung overall acid mole minus yung dinagdag mong titrant. Okay? Sundan. Dito naman tayo sa isa, sa numerator. A minus. Kailan mapoproduce ang A minus, ang conjugate base? Kailan niya mapoproduce? Kapag naglagay ka ng titrant. If the titrant reacts with the acid, doon lalabas ang conjugate base. So, with that knowledge, with that idea, ibig sabihin nun, the moles of the conjugate base corresponds to the mole of the titrant added. Okay tayo doon? The mole of the conjugate base corresponds to the mole of the titrant added. Kasi nung nagdagdag ka ng titrant, dun yung lumabas, 'di ba? Doon siya dumami. Okay? So, ibig sabihin, I can express this, the amount of conjugate base as MTVT. Okay? Gets na. Anong gagawin nyo dito? Okay? pKa, negative log mo lang yung Ka plus the logarithm of the ratio. On the numerator, that's the mole of the titrant. On the denominator, that is the mole of the analyte minus the mole of the titrant. Gets natin? Okay. Sana gets ha. Yan. Tapos na tayo sa pre-equivalence point. And after addition of titrant, then biglang suddenly mag-faint pink na siya. Ibig sabihin nun, we reach the end point. And at the end point, equivalence point din tawag doon. No? Okay, malapit yun sa equivalence point, which tells us that the mole of the titrant is equal to the mole of the analyte. Equal na sila. What happens in our weak acid? Ang nangyayari is that ang weak acid natin, ano na nangyari? Sulat kayong reaction. Dito muna tayo uli sa taas. So, anong nangyari? Complete na yung reaction. No? Complete na yung reaction. Naging ano na siya? Sodium A minus, or sodium and the conjugate base, plus the water. Okay? Do we have HA left? Wala na. No? Lahat sila na-convert na into product. Completely neutralized na sila. So, ibig sabihin, sa equivalence point, ito na lang yung nag-e-exist. The conjugate base and the water. And of course, yung cation. Okay? So, ito na lang yung nag-e-exist. No? Wala na itong mga to. Kasi again, pag sinabing equivalence point, the reaction is complete. No? Sabihin, wala na tayong reactants. Lahat sila naging products na. Okay. So, kaya nilagay ko dito, H2O, A minus. Conjugate base and water na lang ang nandun. Okay? Of the two species, ito question. Sasagutin nyo to. Of the two species, water, conjugate base, which of them will contribute to the pH of the solution? Type nyo yung answer nyo. Makasagot ng tama, magkakaroon ng academic break. Ano yung sagot dito? Water, conjugate base. Sino sa dalawa ang magko-contribute sa pH ng solution? Makasagot ng tama, makahanap ng tamang tao. Madali. Okay. Madali. Sino sa dalawa yung magko-contribute sa pH ng solution? Tubig o conjugate base? Dali, okay lang. Kahit anong idea. Chat nyo dito sa chat box. Dali. Okay lang magkamali. Tubig ba o conjugate base? Hintayin ko sagot nyo. Di tayo magpo-proceed pag wala sagot dito. Kahit mali, okay lang. Dali. Dalawa lang option nyo. Ito o ito. Mini-mini mo nyo na lang. Just ask yourself, yun nga ba sagot? Okay? Kasi di ba kanina last time, sa strong acid, strong base, tubig ang nagko-contribute sa pH. Okay? So may nagsagot, water. Okay. How about the others, no? Any idea from other people? May nagsabi, dalawa, water. Okay. H2O din hula nila. Okay lang, hula lang. Kaya sabi ko nga sa inyo, mini-mini mo. Diba? Mini-mini mo. O, tubig nga. Kapag mini-mini mo, diba? Okay. Sasagutin ko na kasi nag-contribute na kayo. The answer is the conjugate base. Okay. Bakit? Kasi water is water. Ang conjugate base ay base. Okay? Base siya eh. Ibig sabihin, the conjugate base is much stronger than the water. Sumasapaw siya, no? Ibig sabihin, siya yung magpe-predict ng pH ng solution. Okay? Ganon. In the presence of water and conjugate base, ang conjugate base ang magdidikta ng pH ng solution. Why? Base kasi siya. Okay? Base siya eh. Okay? Gets yun? Okay? Kasi yung tubig lang yan. Okay? pH 7 lang yun. Okay? Pero yung conjugate base, mas malakas yun kaysa sa tubig. Okay? Mas malakas ang kanyang basicity, mas mataas ang kanyang basicity kaysa sa tubig. So siya yung sasapaw. Okay. 'Di ba sa strong acid, strong base, strong acid, ang sagot natin doon, tubig lang. Bakit? Kasi sino yung kasama ng tubig? Salt. Asin lang. Okay. NaCl. Okay. So ano pH na? 7 pa rin. But this time, since nga meron tayong conjugate base, yung conjugate base ang magpe-predict. Kasi nga siya ay base. Gets yan? Tanungin ko kayo, with that knowledge, ano ang pH at equivalence point? Is it greater than 7, equal to 7, less than 7? Sige, I want your hula. No? Tatlo ng options mo. Since conjugate base ang nagko-contribute sa pH at equivalence point, what's the pH of the solution? Greater than 7, 7, or less than 7? Okay? Drop your answers na. Okay. Makatamang sagot, makaka-perfect sa final exam. Okay. So we have 3 answers, 4 answers na greater than 7. Ang sagot ay greater than 7. Okay? Bakit? Kasi nga base yun eh. 'Di ba base to, 'di ba? Ibig sabihin greater than 7. Okay? Ganun yung logic, no? So ibig sabihin, since this contributes to the pH of the solution, that means the pH of the solution is basic. No? Basic siya kasi base to eh. Conjugate base. Okay? Ayan. Gets? Ibig sabihin, hindi na 7 sagot natin dito. 'Di ba? Kapag SASB, no-brainer yon. 7 ilalagay mo doon kasi yun na yun eh. 'Di ba? Pag monoprotic WASB, pag weak acid strong base na, hindi na matic 7 yon. Iko-compute mo na siya. Okay? Kasi sabi natin basic. Anong value? Greater than 7. Ano yung exact value? Yun yung problema natin. Hindi natin alam kung ano yung greater than 7 na yun. Basta alam natin lagpas sa 7, no? So, paano natin yung mga compute? Balik tayo sa equilibrium. Okay. So, sabi ko sa inyo, at equivalence point, too big and conjugate base na yung nasa solution. And yung too big and yung conjugate base, they can actually react to one another. And they form HA and OH minus. Okay? So, ito yung mangyayari. Magpo-produce tayo ng weak acid uli and hydroxide. Nag-a-agree yung pusa ko sa likod. Sabi niya, meow meow daw. Okay. Of the two species, sino yung mas malakas? Di yung hydroxide. Strong base yun eh. So, ibig sabihin, ayan, alam mo to kunin, alam mo yung pH ng solution. Okay? So, this equation is described by the base dissociation constant. Bakit KB yan? Kanina Ka kasi H plus lumabas. Di ba sa product side may H plus tayo? This case, OH ang lumabas. Ibig sabihin, base dissociation constant yon. Gets? Okay? Kapag H plus lumabas doon sa product side, Ka yon. Kapag OH ang lumabas sa product side, base yon. Okay? This shows us the reaction of the conjugate base with the water, forming the acid, the weak acid, and the hydroxide, which is a strong base. No? So, ayan yung dahilan bakit basic tong conjugate base natin. Kasi naglalabas siya ng OH. No? If we write the Kb, that can be written as HA, OH minus, divided by A minus. Yung water, di mo isasama because the activity of water is 1. Okay? The activity approaches unity for liquids and solids. Nasa activity coefficient na lecture yon. Okay? Naalala yon? Pag hindi na, okay lang. Okay? So, yan. And using ice table, pag nag-ice table tayo dito, we can rewrite the numerator as x squared, the denominator as the concentration of the conjugate base, minus x. Applying the small x approximation, okay, pag dinivide mo yung concentration by Ka greater than 1,000, we can simplify this as x squared over concentration ng A minus equals Kb. Rewriting the equation, we get x equals square root of Ca minus Kb. The concentration of the conjugate base times the Kb. Okay? Kaya yun yung nilagay kong equation dito. OH equals square root of the conjugate base times the Kb. Gets saan nanggaling siya? Saan nanggaling yan uli? The reaction between these two species. Ano yung reaction nila? It produces OH. Since it produces OH, this is described by the Kb equation or the base dissociation equation. Ito yon. Gamit kayong ice table, magiging ganito yon. Apply small x approximation, magiging ganito yon. Square root of conjugate base concentration times the Kb. Okay? Hindi ko yung kinuha out of nowhere ha. Hindi ko yung dinampot sa hangin. No? May explanation yan sa equilibrium. Kaya nga sabi ko sa inyo, as long as you know the equilibrium, you will know how to solve sa titration problems. Okay? Pero again, shortcut yung binibigay ko. Pag tinignan nyo to sa textbook, ganito yung gagamitin mong equation. Ito. Ito yung equation na gagamitin mo pag nasa textbook yan. Kahit yan ay Harris, kahit yan ay Skoog, no? O kaya mga online YouTube videos ni Khan Academy, ni Professor Dave, ni Organic Chemistry Tutor, Leah Forsyth, AK Lectures, ba't ko alam yun? Nanonood din kasi ako eh. Okay. Nung undergrad, nanonood ako noon kasi mga prof namin absent. Kaya as much as possible, ayaw ko umabsent para Hindi nyo na kailanganin sila. Kasi ako na yung magbibigay ng shortcut. Okay? So, yun. Itong ginagawa natin, shortcut to ha. Nag-small x approximation tayo. Yung nasa YouTube at yung nasa libro, hindi sila nag-shortcut. Kasi doon din naman tayo nanggaling. Nag-shortcut lang tayo para madali, no? Para madali mag-solve. Kasi nakakaiyak eh. Nakakaiyak ang daming equation eh, 'di ba? May iyak ka na lang talaga minsan. Okay. So yan, gets na saan nanggaling to ha? That came from the reaction of the conjugate base and the water. Yan. That is described by the base dissociation constant. Now, paano ko kukunin yung KB? Ka meron ako. You know the relationship Ka? Balik ulit tayo sa taas. Alam niyo yung relationship ng Ka? Kb equals Kw. Alam yan? Dapat alam yan. Okay? Ka times Kb equals Kw, which is 1 times 10 raised to negative 14. Okay? Ayan. Ngayon, paano mo malalaman yung concentration ng conjugate base? Remember, the condition at equivalence point is that the mole of the acid and the conjugate base, nadigay ako, sorry. Ano yung condition at equivalence point uli? Ang mole ng analyte, ang mole ng titrant, equal yon. Okay? So, ibig sabihin nun, So, di ba yung ating acid, yun yung yun yung HA, no? So, dun manggagaling yung A minus din, no? Okay. So, ibig sabihin nun, pwede ko malaman yung concentration ng conjugate base kapag alam ko yung moles ng analyte o kaya ng titrant, no? And I divide that by the total volume, okay? So, ibig sabihin, you can determine this using MTVT o kaya MAVA. Same lang yon? Yes, same lang yon at equivalence point. Bakit? Kasi ano sabi natin at equivalence point? Mole analyte equals mole titrant. So, you can use MTVT pa rin o kaya pwede naman MAVA. Bakit? Kasi sabi natin, A is equal to T. Moles of analyte equals mole of titrant at equivalence point. So, you can interchange these two equation. Pwedeng MTBT, ito MABA. Okay. Again, only at the equivalence point. Equivalence point lang. Kasi nga may equivalence. Okay? So, yan. Emphasize ko yan, ha? Baka kasi mamaya i-apply nyo dito, no? Hindi pwede yun. Na? Dito lang pwede yan. Pwede itong MAVA, pwede itong MTBT. Okay? But again, by convention, analyte yung nilalagay namin. Okay? Kasi sa analyte naman nanggagaling talaga yung A-. Okay? Doon talaga siya. In reality. O, divide mo yan sa B total. Bakit? Dilution. Kung i-cross multiply ko to, M final, V final equals M initial, V initial. Dilution tong formula na to. Okay? So, mole analyte divided by the total volume. So, I just diluted the equation. Ayan na yung pa-plug in mo. Ito yun yung concentration of A. Yung Kb, divide mo lang yung Ka and Kw. No. Ayan na. Nakuha na natin. Next one, post-equivalence. At post-equivalence, meaning nun, napabayaan mo na yung titration mo. No? Ano na, pink na yung solution mo. No? Ano na, susunod maging purple na yun, Barney na yun. No? Okay. So at post-equivalence point, sobrang daming titrant na yun. Sobrang daming titrant na yung nalagay mo. Ibig sabihin nun, the species present are the water, the conjugate base, and the excess strong base. Of the three solutions, sino yung sasapaw? Yung strong base. No? Strong base kasi tayo eh. So yung excess base na yung magpe-predict ng ng concentration, ng pH ng solution. Kung gaano kasobra yung base na yon, yun na yung pH ng solution. And just like last time, the calculation for the excess base is this. MTVT minus MAVA minus all over V total. Okay? So ito, parehas pa rin to sa strong acid, strong base na. Okay? Kasi ang parehas lang condition doon excess na yung base eh. Kaya ganito na yung equation natin. Okay? Ganito uli ang equation natin. Hindi na kailangan ng stoic dito kasi yung hydroxide na yung sumasapaw sa conjugate base. Okay? So this is mole titrant, mole analyte over V total. And may ipapakilala akong bagong equation. This new equation is the same as this one. Same lang yan, opo. Bakit? Ano ba yung kinukuha natin sa numerator? The excess mole of titrant. Okay? Excess mole of titrant. No. Pwede mo gawin is ganito na lang. Ipag-subtract mo na lang yung sobra sa equivalence point. Pag binultiply mo yung sobrang volume, starting sa equivalence point, times the molarity of titrant, excess mole na yun ng titrant. Gets ba? Okay. So, ano nangyari? Yung sobrang volume ng titrant, yun ay excess moles eh. Di ba? Hindi na lang gawin mo. Multiply mo na lang kung gaano kasobra yung titrant mula sa equivalence point. Saka mo siya i-multiply sa molarity. Same lang yung makukuha mo if you use this or this. No? Kasi ano yung kinukuha natin dito sa dalawang to? Kung gaano kasobra yung titrant. Okay? One way of solving for gaano kasobra yung titrant is gaano kasobra yung volume niya. And from the volume, if you multiply that by the molarity, you get gaano kasobra yung moles ng titrant. Okay? So, kahit wag nyo na ito gamitin, itong equation na to, pwede nyo ito gamitin sa kahit ano. Basta excess. Okay? So, you can use this sa strong acid, strong base, strong base, strong acid. No? Pwede ito gamitin. So, VT minus VTEP, MT over V total. Okay? Gets bakit naging ganon? Bakit? Kasi mini-measure natin dito sa parenthesis is yung sobrang amount ng titrant. Pwede ganito na lang. Then, in-negative log mo yan, POH yan, 14 minus POH, pH. Okay? So, yun yung dahilan bakit ganito yung equations natin. Again, hindi dapat sapat ang sabihin na gamitin nyo na lang yan na hindi tayo ganon. Na. Ayan, papansin nyo, pag nag-explain talaga tayo, lahat ng math na lang, sasabihin natin lahat ng math. Kasi, there should be an explanation to why the equation looks like this. No? Okay? So, ganun dapat kapag college na. Tanungin nyo parati teacher nyo, bakit po ganyan yung equation? Dapat may explanation yan. So, ano yung sagot natin dito sa tatlo? Ang explanation natin dito is equilibrium. Dito sa post-equivalence point, since yung excess base na yung dahilan ng pH ng solution, kasi this is stronger than this, so ibig sabihin, alamin mo na lang kung gaano kasobra yung titrant. Ito na yung equation natin. Gets? Sana naintindihan yan, ha? Okay. So, in-explain ko lang yung equation. Pero syempre, hindi ko lang kung kakalimutan nyo yon. Pero wag nyo kakalimutan, ha? Although, ito lang yung gagamitin nyo talaga pag nagsosolve kayo. Huwag nyo kalimutan saan sila nanggaling. Okay? Huwag nyo kalimutan saan sila nanggaling. Sir, yung equation, pwedeng gamitin po pag excess base or excess titrant po. Yes po. Itong equation na to, MT, this can be used to determine yung excess base o kaya excess acid. No? Kapag excess base, OH yung masosolve mo. Kapag excess acid, H+. The equation is still the same. Okay. Kunwari, titrant mo, acid, edi H+ equals this. Okay, excess moles to eh. So, this can be used sa strong base, strong acid, strong base, weak acid, strong base, and sa next, yung weak base, strong acid. Okay? So, ayan. So, ito lang yung pwede mo gamitin kahit saan. Yung dulo lang, yung post-equivalence lang yung pwede gamitin kahit saan. Okay? Pero itong mga first three, hindi pwede gamitin kahit saan yan. Okay? Hindi pwede gamitin kahit saan. Take note na kung ano yung titrant mo, yun yung masosolve mo dito. Kunwari, titrant mo, strong base, edi OH yun. Pag ang titrant mo, strong acid, edi H plus to. Okay? So, yun. This is the titration curve for WASB titration. Again, your weak acid is the analyte, so you start with a very low pH. Upon the addition of the titrant, the pH will slowly increase, and you are now in the region called the buffer region, wherein there is a minimal increase in the pH compared to the volume change. No? Ayan, tignan nyo. Ang laki ng, ang laki ng volume change, no? Delta B. Pero yung pH range, maliit lang. So, ibig sabihin yan, this is a buffer solution. Ang daming volume nilagay mo, onti lang nagbabago sa pH. Buffer yan. Kasi by definition, buffer are solutions that resist pH changes. Okay? Then once the buffer is destroyed, you will reach this, tawag dito, inflection point. And take note that in the inflection point, you will find the equivalence point. And since sabi natin, ang equivalence point ay basic, mas mataas yan sa 7. Okay? So the pH at equivalence point is greater than 7 because of the presence of the conjugate base. Post-equivalence, sobra na yung titrant dito. So the pH of the solution is predicted by the excess titrant. Okay? And now, practice. Generate a titration curve of 50 ml of 0.1 molar acetic acid, abbreviated as HOAC, Ka 1.8 times 10 raised to negative 5, with 0.1 molar sodium hydroxide at 25 degrees Celsius. Ako na rin, wala tong title na to. Wala yan title na yan. Hindi natin alam anong type ng titration to. Hindi ko alam, no? Ano gagawin mo? Kung sino yung unang binanggit, siya yung analyte. Okay? Kung sino yung huling sinabi, siya yung titrant. Ano yung analyte natin? Acetic acid. Dapat, alam nyo na yung acetic acid ay weak acid. So, this is WA. And yung sodium hydroxide, ito ay strong base, SB. So, this titration is WASB type of titration. Important malaman to? Yes. Kasi remember, 16 equations meron tayo for monoprotic acid-base titration. We have equations for SASP, SBSA, WASB, WBSA. Doon sa 16 equation, dapat alam mo kung ano yung combination ng equations ang kailangan mo. How? Alamin mo kung anong type lang ng titration ginagawa mo. In our case, the analyte is weak acid. The titrant is the strong base. So we use the equations for WASB, which has been explained to you earlier. Okay? Ayan yung mga equations na yan. Okay? So given those equations, ano yung susunod natin gagawin? Hanapin si VTEP. Hanapin natin yung best friend natin. Find VTEP. Recall at equivalence point, the mole titrant equals mole analyte. Okay, so this can be expressed as MT VTEP equals MAVA. Hanapin mo yung best friend natin si VTEP. So this is MAVA over MT. Plug in, okay? So MA 50 0.1 divided by 0.1. Si VTEP ay 50 ml. Alam nyo na kung paano mag-solve niyan. No? Dito lang yung galing. Sir, saan to galing? Sa kondisyon ng equivalence point. Equal sila at equivalence point. Kaya nga equivalence point tawag doon. Gets yan. Okay? Sometimes the word itself is the definition. Okay? Yun na, equivalence point. Adi yung point ng equivalence. Diba? Ibig sabihin, equal sila. So we now know 50 ml is the EP. Ibig sabihin, we can now assign stages to the other volumes. No? Pwede na tayo mag-assign ng stages to the other volume. Initial, pre, and post. Alam na natin yung stages, apply the equations. Tingin na lang kayo sa previous equation kung di kabisado. Ako medyo kabisado ko na kasi kahapon ko pa to din i-discuss. Okay. Okay. To be honest with you, ako kahit 'di ba teacher nyo ko, malamang teacher nyo ko. Hindi ko talaga kabisado yung mga equations. Kaya ginagawa ko kunwari nakalimutan ko yung equation, babalik ako sa equilibrium. Okay? Ganun ka-important yung equilibrium. Pag hindi nyo kabisado, kapag hindi nyo alam yung equilibrium, lost na kayo sa anachem talaga. Ganun ginagawa ko. Hindi ko talaga kinakabisado lahat ng equation na yan. Nakatamad eh. Alamin ko lang equilibrium, tapos saka ako magde-derive. Okay? Kasi noong college, share ko lang. Sige, pwede na kayo mag-start mag-solve, no? Sunod na lang ako kasi mabilis lang ako matapos dito sa solving. Okay. Nung college ako, wala kaming index card. Tapos face-to-face classes pa yon, no? Struggle. Tapos ang equation nun, ang dami. Imagine mo, 16 tong equation na kabisaduhin mo, no? Monoprotic pa lang yon. Wala pa yung diprotic, triprotic. So, kailangan, alam mo talaga equilibrium kasi yun yung sasalba sa'yo, no? And so far, so good naman. Okay naman yung scores ko nun. Tapos na kayo dito? Okay, so ako naman. Initial pH, you know that's square root of Chaka. Concentration acid is 0.1 times the Ka. 1.8 times 10 raised to negative 5. I-negative log mo na lang yan. Di ko na ipapakita. Negative log 0.1 times 1.8 times 10 raised to 5. (1.8 times 10 raised to negative 5). Okay, so yan, 5.74. Okay. Teka lang. Nakalimutan ko pala square root, sorry. Sorry. Kalimutan ko square root. Kaya nakaganon ako kanina pa. Sabi ko, ano yun? Nakalimutan ko square root, sorry. Ayan. 0.1 times 1.8. Na-distract ako kasi yung pusa ko nagkakalkal eh. Ayan, ayun. Yun yung sagot. 2.87. Ayan ha. Wag kalimutan square root. Ako na, nakalimutan ko eh. Wag niyo kakalimutan ha. Wag tularan. 2.87. Kapag medyo weird yung sagot nyo, no, titigan nyo uli. Okay. Ganun na ako eh. And sabi ko, ano yun? 5 point something. Ayan na. 2.87 na. Nakuha yan? Kuha yan. Kasi nasa next slide yung sagot eh. Na huwag kayo tumingin dun. Huwag madaya. No? Solve muna tayo bago natin tignan yan. Okay? Pre-EP. Ito, pre-EP. This is Henderson-Hasselbach Equation. Let me write dito sa baba. pH equals pKa plus log. Moles na lang ilalagay ko Mole of the conjugate base, mole of the acid remaining. Tapos take note na yung mole ng conjugate base ay MTBT. Ang mole ng conjugate, ang mole ng remaining acid ay MAVA minus MTVT. Ayan, plug in mo lahat ng numbers doon. Okay? Ang pa-plug in ko lang, i-plug in nyo rin. Huwag titingin sa kabilang slide. Huwag madaya. Okay? Kailangan lahat tayo magdusa muna. Okay? By the way, pKa. Ang pKa ay negative log lang ng Ka. Solve natin yon. Negative log 1.8 times 10, negative 5, 474. 474 na kunin natin. Okay? 474 plus log. Or gamit ako ng colored ink. Ganon din gawin niyo pag nagre-review. Ha? Pag nagre-review kayo, gamit kayo colored ink para di kayo malito. Ganitong color si MT, ganitong color si si analyte. Okay? So titrant ko is orange. So that's 0.1 times 10. Analyte ko is red. 50 times 0.1. Minus yung orange. Ayan na. Salpak nyo sa calculator yan. Pindot-pindot. Kaya pindot tayo. 474 plus log fraction 0.1 times 10. Parenthesis tayo dito. 50 0.1 close minus open 0.1 times 10 close equal sign, ayan, 4.14. Round off nyo to 2 decimal places. Ayan ha, pag tinype nyo sa calcu, kailangan ganito nakalagay sa calcu nyo ha. pKa log, ayan, ano to, MTBT, MAVA minus MTBT. Okay. Dito sa 25 ml, ganun din. Palitan mo na lang yung 10 ml ng 25. Okay? Kopyahin mo na lang yan. Mas mamaya, tatanungin ko kayo uli. Kapag may question, itanong ha. Ang daming numbers eh. Yeah. Na-expect ko may mga questions kayo in mind. Okay. Yung 10, gagawin lang natin 25. Huwag nyo burahin yung calculator nyo. Yung calculator talaga yung binura. No? Huwag nyo palitan yung nilagay nyo dito. Yung 10, palitan mo lang ng 25. Ganun din sa taas. 25. Equal sign. 474. Okay? Ayan. Bago ako mag-proceed sa next one, tatanungin ko kayo. Ano napapansin nyo? Ano napapansin nyo? Hindi ko sasabihin kung ano yung kailangan nyo tignan, pero dapat may mapansin kayo. Sige. So, dito sa pre-equivalence point, kailangan may mapansin kayong number. Ano sa tingin nyo yung nakikita ko na hinahanap nyo? Comment nyo na lang sa chat box natin. Ano sa tingin nyo yung gusto ko mapansin nyo? Same yung pH po. Saan? Sa kapareha po ng pKa yung pH. Anong volume? Yung 25 na. Yun. Yun yung gusto ko mapansin nyo. Nice, nice. Good tayo dun. Okay? Ayan, a good observation. Papansin nyo, at 25 ml, pH is equal to the pKa. Bakit? Bakit? Yan yung tanong natin sunod. Bakit? Bakit kaya nawala tong log? Zoom in ko. Bakit sa tingin nyo nawala yung log? Kasi, ito mathematical to kaya ako nang sasagot. Kasi, ano yung logarithm of 1? Type nyo sa calcu nyo. Log 1. Delete natin. Log 1. 0. Okay? So that means, kaya to naging ito equal dito kasi 0 to. Or basically, log of 1 to. That means, kapag 1 yung fraction na to, ano meaning nun? Kung ano yung value ng numerator, yun din yung value ng denominator. Is it? Tignan natin. 25 times 0.1, 2.5. 50 times 0.1, 5 minus 25 times 0.1, 2.5. 5 minus 2.5 is 2.5. Ibig sabihin, the numerator or the moles of the conjugate acid is 2.5 millimoles. And sa denominator, ang moles ng remaining acid ay 2.5. So, 2.5 divided by 2.51. Ibig sabihin, halfway to the end point, papansin nyo, ito 50 ml, ito 25 ml. Pag halfway ka na sa end point, the mole of the conjugate base and the mole of the remaining acid is equal. And that causes the pH to be equal to the pKa. Again, kailan yun ma-observe kailan makikita kung equal na yung dalawa? They will only be equal if you are halfway done, no? Pagkalahati ka na, malapit mo na matapos. Pag 50% ka na papunta dun sa end point, dun to ma-observe, no? O, take note nyo yan. Sulat nyo yan sa notes nyo. At kalahati ng end point, pH equals pKa. Okay? Halfway ka na. Okay? So, ganun nangyayari. So, isipin nyo yung titration. O, ito yung kamay ko. O, ito yung ito yung acid. Ito yung conjugate base. O, initially, ganito yon. Wala akong conjugate base. Ang dami kong acid. Then, halfway sa titration, equal na sila. Pag nilogarithm mo yung equal, 0 yon. Okay? So, kapag equal na yung mole ng conjugate acid, ng conjugate base pati ng acid, pag equal na yon, pH equals pKa. Okay? So, nag-i-exist lang yan kapag halfway done ka na. Kasi equal na yung amounts nila. Okay? Pero again, hindi pa yun yung endpoint, ha? Hindi pa tayo tapos sa reaction. Gets yan? At halfway to the endpoint, pH equals pKa. Okay. Kasi tatanungin ko yan sa quiz and sa exam. Okay? Tatanungin ko kayo nun. Kaya, paki-note yung mga inuulit-ulit ko na maisipin nyo, paulit-ulit naman to si sir. Ganun talaga. No? At least hindi niyo ako masasabi na hindi ko sinabi. Ulit-ulit ko nga sinabi, di ba? Okay. So ganun ha. Again, if you are halfway done sa titration, pH is equal to pKa. Halfway lang. Kalahati lang, okay? Gets 'yon? Hopefully gets. EP, ano to? Conjugate base na meron tayo dito. OH equals the concentration of the conjugate base times the Kb. Okay? Paano kinukuha yung concentration ng conjugate base? Pwedeng MTVT over V total. Pwede namang MAVA over V total. Parehas lang yun. Bakit? Kasi equivalence point tayo. Equivalence point, no? Equal. Okay? So, gamitin natin MAVA kasi yun yung convention. Yun yung nakasanayan namin. Okay? So, ano nga ba yung MAVA? O, yung analyte, kulay red. Okay? 50, 0.1. V total, ano na yung total volume natin? 50 ml analyte. Sabi yun sa problem sa taas. 50 ml titrant. Ito oh. Yun. So ito yung concentration ng analyte. Times. Kukunin mo na yung Kb. So again, sabi ko Ka, Kb equals Kw. Okay. So if you want to solve for the Kb, that's Kw over Ka. So that's 1 times 10 raised to negative 14 divided by, ano yung Ka? 1.8 times 10 raised to negative 5. Then solve for pH. Okay? Pwede mo na i-solve yung pH niyan. Papakita mo kung paano ako magpindot sa calcu. Siguro naman ganun din yung iba sa inyo eh. 'Di ba pag ni-negative log mo yan, POH yan. Gawin mo na sa calcu para pH na yung lumabas. Ganito. 14 minus log ng concentration ng OH. Okay. Tapos i-plug in mo tong square root na to dito. Isang pindutan na. Okay? Kasi tamad ako mag-isa-isa eh. Nakakatamad yung daming pinagpipindot sa calcu eh. Yung ginagawa ko, isang pindutan. Isang bagsakan. No? Either tama yung sagot or isang bagsak talaga sa sagot na yan. Okay? So, yun yung mga option eh. Isang bagsakan in a good way or in a bad way. Okay? So, ganyan na lang. 14 minus log. No? Again, bakit yung ganito? POH to eh. Adi, kung gusto mo pH, edi 14 minus POH. Okay? Gets yan? Sana gets na. Times 0.1. Pina-plug in ko na. 50. 50. Times, fraction ulit. KW divided by Ka 0.8. Yan yung sagot, 872. Pakita ko sa inyo yung calcu. Hindi kasi ito na-extend eh. As in, yan lang talaga yung size niya. So anyway, ganyan lang. 14 minus POH, which is negative log. Concentration ng conjugate base times KB or KW over KA. Equal sign, yun yung pH. Ano napansin nyo? At endpoint, the pH is 872. Greater than 7 nga. Ibig sabihin, tama yung hula nyo kanina. Actually, hindi yun hula. Ano yun? Tawag namin doon ay wise guess. No? O kaya intuitive guess. No? Okay. Kasi pag sinabing hula, ano lang yan eh. Parang hindi pinag-isipan. Yung ginawa natin, pinag-isipan yan. So, wise guess. Yan. Diba? Tama yung ating wise guess. Greater than 7 nga ang pH at endpoint. Okay? Galing, no? Post-equivalence na tayo para matapos na to. Post-equivalence points. Nabulol na ako. Post-equivalence point, sobra na yung titrant. Okay? So, makukuha natin yung OH. Gamitin na natin yung new equation. VT minus VTEP times MT over V total. Okay? VT, ano na yung VT natin? 50.1 minus, ano yung VTEP? Ang volume of titrant at equivalence point ay 50. Okay. Times the molarity of titrant, 0.1. Divided by the total volume. Again, pag sinabing total volume, analyte plus titrant. 50 ml analyte. 50.1 yung titrant. Okay? So, analyte titrant. Okay? Makuha mo yung OH niyan. Negative log, magiging POH. No? 14 minus that. pH. Plug in ko sa calcu. 14 minus negative log fraction 50.1 minus 50 close times 0.2. Sa baba, 50 plus 50.1. 9.999. Okay, o 10 na yan. Pag ganyan. Gets natin dyan. Hopefully, satisfied kayo sa ating solution. Okay? So, yan. Na-explain na natin bakit ganun yung sagot sa next slide. No? Let me bring you to the next slide. Ayan. Alam nyo na kung bakit ganyan yung nakalagay dyan, ha? Okay? Kung nag-advance study kayo, edi good. Pag nag-advance study pero hindi naintindihan, edi ayan na. Sana naintindihan na ngayon. Okay? Pero pag di naintindihan, pakitanong na sa akin, ha? Para ma-explain natin. Ayan. Ang daming equation, no? Okay. Ayan. Hindi ko na siya ita-titration curve. Nakakatamad eh. Okay. I want you to work on this at ano na lang. Kayo na bahala mag-work dyan. Upload ko yung answer by the weekend. Okay. Sagot lang kayo niyan muna. No. Skip ko na to, ha. Activity nyo na to. Slide number 24. Next one. Skip ko na yan, ha. Kayo na bahala doon. Upload ko naman yung sagot eh. Okay. So next one, we have the weak base strong acid titration. Again, baliktad tayo. Weak base ang meron tayo, strong acid ang titrant, no. Analyte to, titrant 'yon. Okay. So ganun pa rin for stages, and for each stages iba-iba yung species and then the equations are different. Let's explain this. Okay? Explain natin to para mas magets. Okay. Again, hindi dapat tayo satisfied. O, gamitin nyo to. Hindi ganun, ha? Huwag ganun. Tanungin nyo parate, bakit po yan yung gagamitin ko? Okay. So, hindi kasalanan magtanong. Okay. Dapat nga nagtatanong kayo. Students kayo eh. Okay. So, we have 4 stages. Ito yung species. Ito yung equation. Paano tayo nakakuha niyan? Okay. Initial tayo. Okay. Yung ating weak bases, we know it's nagdi-dissociate yan. Okay? So, parang acid lang din yan. So, let us show the dissociation reaction of the base. So, ang solution natin dito, may base, may tubig. Okay? Ano nangyayari? Yung weak base, when it interacts with water, it forms an equilibrium to produce BH+, which is the conjugate acid, plus the OH minus. Ito yung nangyayari. No? Yung base, kapag nag-i-interact siya with water in our solution, it produces the conjugate acid and the hydroxide, which is a strong base. Kaya basic yung ating base, no? Kasi it produces OH. Okay? Anong definition to? Ito ay Arrhenius definition. The base produces the OH. No? Okay. Pero ito yung conjugate, Bronsted-Lowry yun. Okay. Anyway, so yan. So since we produce the OH, this means that this equation is governed by the base dissociation constant. Kasi naglabas tayo ng OH. Okay? So kapag OH ang nilabas, Kb yun. So let's write the Kb, product over reactant, concentration, BH plus, OH minus, divided by base. Yung water, di sasama because the activity of water is 1. Okay, so wala kang ilalagay doon sa baba. Apply mo yung ice table natin, Kb equals x squared divided by concentration of base minus x. Assuming that we can use the small x approximation, assume na natin, assumera tayo dito. Assume mo na, this can be reduced to x squared equals Cb Kb, or x is equal to the square root of Cb Kb. Ayun. Sundan, saan nang galing? Hindi yung kinuha somewhere, ha? Doon yung galing sa equilibrium. Pag nagbasa kayo ng libro, ito yung ibibigay sa inyo. Pero again, pwede mo naman i-approximate. Ganito na lang. Mag-effort pa kayo mag-quadratic. Sayang naman oras natin doon, 'di ba? Ganito na lang. Okay, gets? Doon yung galing ha. Kasi ang mga itatanong ko sa inyo, most likely, umiikot dito sa explanation na to. Okay? Kaya ayun. Okay, so that's our initial pre-equivalence. What happens here is that we are now adding titrants. Dadagdag na tayo ng titrant. So nababawasan na yung base, dumadami ang conjugate acid. Okay? So kapag ganon, we have a buffer system. Okay? And you know, the buffer system ay galing sa equilibrium constant. Nabura ko na eh. Okay, so pag ni-negative log mo yung equilibrium constant, i-rewrite mo yon, lalabas tong equation na to. Okay? So this is the equilibrium, this is the Henderson-Hasselbach equation for the base. No. Kung kanina, pH, pKa, conjugate base over acid, pag base solution tayo, POH, Kb, conjugate acid base. Okay? Baliktad lang. PKB, paano yan? Negative log mo lang yung KB. Focus ulit tayo dito sa dalawa. Again, imo-moles na lang natin yan. Mole na lang yan. Kasi again, same container, same volume, pwede mag-cancel out ang volume. Kaya moles na lang. Base. Sabi natin na babawasan ang base, di ba? So, ang remaining base ay N base minus the mole of the acid added. Okay. Doon mo malalaman, gano'n na lang karami yung natira. Okay. So, yan na yan. N base minus mole acid. And again, yung base, ito yung ating analyte. So, this is MAVA minus MTBT. Ganun pa rin. Okay. MAVA minus MTBT. On numerator, this is the conjugate acid na dadagdagan yan when the titrant reacts to the base, di ba? So that means equivalent yung mole ng titrant sa dami ng conjugate base natin. So depende sa gaano karaming titrant na inalagay mo, yun na po produce na conjugate acid. No? So we say that this is also MTVT. Okay. Papansin niyo, no? Paulit-ulit lang tong paulit-ulit lang sila, no? MAVA, MTBT, nakikita niyo sa SASB, di ba? SBSA. Hanggang dito, kita nyo pa rin siya. Ulit-ulit lang na. So, yan. Gets na yan, ha? Ni-reverse lang natin, eh. At equivalence point, we do not have any B anymore. Wala na tayong base. They are all converted to the conjugate acid, no? So, let me show the equation. Kunwari, B plus HCl. Anong mangyayari dyan? Maging BH, no? Plus yung salt. And syempre, may tubig dito sa paligid, no? Kaya nilagay ko dito, tubig, pati HB+. Yung tubig, hindi pwede mawala yan, no? Okay. Dehydrated yun, no? Kailangan may tubig parate, no? Ngayon, of the two, ito, tanong tayo ulit. Of the two species, sino ang magko-contribute sa pH ng solution? Water, conjugate acid. Drop your answers. Again, of the two species present at equivalence point, sino sa dalawa ang magko-contribute sa pH ng solution? Is it water or the conjugate acid? Text nyo na yung sagot nyo. Type nyo na. Wise guess dapat. Kahit hula lang, mag-mini-mini, mo uli kayo, okay lang. Then explain ko bakit yun yung sagot. Dali, lagay nyo na yung hula niya. Okay? Sagot, conjugate acid. HB or the conjugate acid. Conjugate acid. Okay? Ang sagot ay conjugate acid. Tama, tama. Nakita niyo yung pattern. Okay. Pag may conjugate base and water, conjugate base yung magko-contribute sa pH. Kapag may conjugate acid and water, conjugate acid yung magko-contribute sa pH. Okay. Kasi mas malakas sila, mas stronger yung kanilang acidity or basicity compared to water. Okay. Given that, ito next question. What is the pH at equivalence point for WBSA titration? What is the pH at equivalence point for a WBSA titration? No, kunwari final exam to. Ano pH niya? Greater than 7, equal to 7, less than 7. Okay, less than 7, less than 7, less than 7, less than 7. Sagot ay less than 7. Ayan. Tama, tama. Nagigets na. Kikita niyo yung pattern, no? Kabaliktaran lang siya ng weak acid, no? Kapag weak acid at equivalence point, pH greater than 7. Bakit? Kasi conjugate base yun nasa solution. Dito naman, kapag weak base, acidic yung kanyang equivalence point. Kasi may conjugate acid. Diba? Kita niyo yung logic doon. Okay, kung sino yung present, siya yung magdidikta ng pH. Now, paano natin nakuha to? Paano to nakuha? No. So, to get this, we need to know the reaction between the two. The water and the HB. No. Parang ginawa natin din dito. Pakita natin yung reaction nila. At equivalence point, this is what happens. No? So, HB plus H2O. It will just produce H3O plus, which is a strong acid, and B, which is a base. So you can see we produce H3O plus. Zoom in natin. Yan. So the reaction of the conjugate acid and the water is shown here. The proton is transferred to water, no? Okay, kasi acid to, it will transfer the H to water. It will produce H3O plus, and the base will also be produced, no? But again, of the two species sa product, water ang stronger, no? Stronger to. Kasi nga weak to, di ba? It is stronger to. So that means we produce H plus, so this is governed by Ka. Kapag OH ang na-produce, Kb. Kapag H3O or H plus yung na-produce, Ka. Let's write the Ka. Numerator, H plus na lang yon. And yung denominator, yung reactant. Okay. Water, di ilalagay. Ice table kayo dyan. No? Tamang yellow lang. So you have the CbH plus minus X. Assume small x. Oops. Assume small x. Pwede na yung burahin. So this can be abbreviated as Ka equals X squared over CbH plus. And X is equal to the square root of CbH plus Ka. Kita nyo? Saan nanggaling yung equation kanina? Sa ice table lang din. Sa equilibrium lang din. Ayun, no? Okay? Gets na saan nanggaling? So, hindi pwede yung basta sundin mo na lang yan. Sumunod na lang kayo, no? Hindi ganun. Kailangan nag-iisip bago sumunod, no? Okay. Alam nyo na kung saan yung related, no? Sumunod na lang kayo. Hindi. Kailangan nag-iisip bago sumunod, no? Ayan. Ito yung explanation kung bakit ganun. Okay. Yung Kb, Ka, alam nyo na i-convert yan. Ka times Kb equals Kw. Ngayon, paano sinasolve yung concentration ng BH+? Similar lang din kanina, no? Kasi sabi natin at equivalence point, MAVA equals MTVT. Okay? The mole of the analyte equals mole of the titrant. So we still follow the same equation. Pwede itong MAVA divided by V total. Pwede rin namang MTBT over V total kasi equal na yung moles nila. Okay? So, yan. Pero again, by convention, we follow the analyte. No? Kasi dun talaga nanggagaling yung ito eh. Okay. In molecular sense, dun talaga siya galing. Okay? Kaya MAVA gamit namin. Although you can use MTBT. Pero ito yung convention. Okay. And then sa post-equivalence, ito na yung species mo. You have water, the weak, the conjugate acid, and the strong acid titrant. Sino yung mas malakas? Excess acid. No? So, excess acid ang malakas, so siya yung magdidikta ng pH ng solution. Katulad ng sabi ko sa inyo kanina, you can use the same equation. Okay? So, papansin nyo, always same yung equation natin at the end, no? Galing, no? Okay. Since acid to, H plus makukuha mo. Okay? Kapag base yan, katulad kanina, OH yun. Okay? So, di ko na uulitin pa, no? Ulit-ulit na, no? Last time pa ako naggaganon na. Okay? So, we follow this same equation. So, ito na lang gamitin natin. VT minus VTEP MT over V total. Okay, so again, we discussed the three again. Itong tatlo, galing lang to sa equilibrium, no? Dalawang equilibrium equation pinakita ko. And doon natin na-derive yung mga sagot. Again, emphasize ko ulit, yung nasa libro at nasa ibang YouTube channel ay iba sa videos natin. At iba siya sa nakalagay sa atin. Kasi doon sa YouTube channels na iba, pati sa libro, ito yung sinusundan nila equilibrium. Tayo, nag-small x approximation. Bakit? Para mas madali. Okay. Para hindi na tayo mag-quadratic. No? Hindi naman kayo BS kami. Kaya shortcut na lang gagawin natin. Okay? So, yan. This is the titration curve. So, this is familiar. Buffer region, inflection point. Okay? So, ganun pa rin naman. Nakakwentuhan ko na to last time. So, let's try to answer this. A 50 ml alico of 0.05 molar sodium cyanide, Kb is 161 times 10 raised to negative 5, is titrated with 0.1 molar HCl. Ano una niyong gagawin? Yung unang sinabi, yun yung analyte. Yung huli, yun yung titrant. Okay. So, alamin mo. Sodium cyanide. Pag binigay yung Kb, ibig sabihin nun, weak base. Yung titrant HCl, strong acid. So, alam mo na yung equations na gagamitin mo. Yung nasa WBSA equations. Okay? Yan. So, alam ko na yung equations na gagamitin ko. Yung nasa WBSA. Ano susunod? Hanapin ang best friend nyong si BTEP. No? Si BTEP. No? How to solve for BTEP? Again, we assume NT equals NA at equivalence point. MTBT, MTVTEP, MAVA, no? Divide mo yan, ang makukuha mo ang sagot ay 25. Okay? Ano yung shortcut ko dito? Ganito na lang shortcut ko. Share ko lang. Yung yung non-zero digits, yun yung minumultiply ko. Then, saka ko siya i-divide sa non-zero digit ng titrant. Para kaya i-mental. Okay? So, paano yan? 5 times 5, 25. Divided by 1, 25. Ibig sabihin yung sagot, either 2.5, 25, o kaya 250. Okay? Yun yung gumagalaw sa isip ko. Ano? Isang tingin mo na lang, okay, 25 yung sagot. Ito yung sagot. Ganun na lang. 5 times 5 divided by 1. Okay, 5 times 5, 25 divided by 1, edi 25. So, ang sagot, either 2.5, 25, or 250. So, nakalagay dito sa table ay 25. Edi yun yung sagot. Easy, di ba? Okay. Halatang nagmamadali na. Ganun. Kailangan along the way dapat may mga shortcut kayo na kikita, no? So, okay. So, lamang ang may alam pero yung may shortcut, yun yung unang matatapos. Okay? Yun yung maunang matatapos sa quiz, no? Yan. Kaya kailangan bukod sa may alam tayo, kailangan may shortcut din tayo. Initial, pre, and post. Okay? O, wag kayo titingin sa next slide. Nandun yung sagot eh. Write na natin yung solution. Okay? Solution, pH calculation. Initial. So, base to. So, this is CBKB. No? OH makukuha natin doon. CB, which is 0.05 times KB, 1.61 is 10 raised to negative 5. That's a negative log nyo yan, okay? Dito tayo sa calcu. 14 minus negative log. Ala, sir, bakit may 14? Kasi POH 2 eh. 'Di ba? POH yan. I-14 minus mo na, no? 14 minus POH na. Para isang pindutan lang. Wag kalimutan square root. Ako nakalimutan ko kanina. Kaya napatulala ako. Okay, 0.5, 1.61, negative 5. And 1095 now. So, yan yung pH initially. 1095. Okay. So, ito yung tinype ko sa calcu. 14 minus log, negative log, square root of CB, KB. Okay. 1095. Kuha iyon. Dapat kuha yan. Nasa next slide na ngayon sagot eh. How about pre-equivalence point? Yung base counterpart tayo ng Henderson. Okay? So that's POH equals PKB plus log and conjugate acid and base. And we know na yung conjugate acid ay MTBT. Ang remaining base ay MAVA minus MTVT. Plug in mo na lang yung numbers. Okay? Plug in. Kunin natin yung PKB. Ano ba yung PKB? Naantok pa rin ako hanggang ngayon. Imagine nyo, umagang-umaga nagsosolve tayo. Dapat tulog pa tayo ngayon eh. Negative 5. 479 yung PKB. Okay? 2 decimal places. Plug in natin. Ano to? 479, no? Gagawin kong colorful para kita. Titrant is orange. No concentration titrant, 0.1 times 10. Analyte is, ano yun? 5005. Okay? Plug in na maigi. Mas maganda kung colored ball pens meron kayo o kaya meron kayong highlighter para hindi kayo malito sa titrant analyte. Okay? Pa-plug in ko yan dito ha. Ayan, baba natin para kita. POH yung makukuha ko dito ha. Again, POH na. 14 minus POH na lang tayo mamaya. Okay. 479 log 0.1 times 10 parenthesis 50 times 0.5 close parenthesis minus 0.1 times 10. Oops. Kalimutan ang parenthesis. Actually, yung parenthesis, hindi ko siya nilalagay talaga, no? Pero gusto ko lang masanay kayo. Yan. So baka isipin nyo, ala, ang acidic. Hindi. pOH yung nakuha natin. Okay? Chill lang. pOH yan. Okay? Okay. Yan. Sa pOH kasi yung kinuha natin. O mag 14 minus that na lang tayo. 14 minus that pH. Okay? So again, yung pOH na nakuha natin kanina, yung 3 something, ha? Okay? So 14 minus ano na lang para makuha mo yung pH. Okay? 1059. Okay, so 1059. Ayan, bumaba yung ating pH. Equivalence point, H plus na to, no? Yan. Ano ulit to? Concentration ng conjugate acid times the Ka. Okay. Ano yung concentration ng conjugate acid? MAVA. Okay. So, MAVA. Over V total. Yung analyte, 50. Yung titrant, 25. Okay. Yung Kb gawing Ka. So, 1 times 10 raised to negative 14 divided by the Kb, which is 1.61 times 10 raised to negative 5. Yung negative log mo yan, pH na yan. Negative log na natin, ha? Ano ba talaga? 0.05, di ba? 0.05. Nakalimutan akong 0. Nakita nyo yung muscle memory. Alam niya may 0 doon, pero ano, yung sinulat ko doon, 0.5 lang. 50, 25. Kahit inaantok ka, kaya mo isolve, di ba? Times negative 5. Ayan. So this is the pH of the solution, 5.34. Again, let me show you. Sa pre-EB. Ay, oo nga, no? Ayun. So thank you. Oo nga, no? Sorry. Ayun, 0.5 yun. Inaantok na talaga ako. Sensya na. Let us correct yung sa 10 ml. Yung sa Okay, so thank you for that. Yan. Share ko kung bakit ako inaantok. Kasi, ganito yung nangyari. Akala ko, hindi ako nagising sa alarm. Akala ko hindi ako nagising sa alarm. Kasi may araw na eh. Kasi may first class ako kanina. Yung pala, mas maaga pa ako sa alarm clock. Ayun. Hindi na ako nakatulog uli. Kaya, puyat-puyat ako. Tapos yung class ko na yon, English, no? English talaga yun, no? Kaya, nosebleed. Let me recalculate ng ayan sa 10. Okay, pasensya na. Thank you for pointing it out. Ang weird na yung ganun. Akala mo hindi ka nagising pero naunahan mo pa alarm clock mo. Times 10. 14 minus that. Ay, lolo. Ayan. Ayun, 9:39. Okay, so yan. So thank you. 9:39. Ayan, salamat. Yan. Okay. So, yan na. Nakuha natin yan. Post-EP, sobra na tayo ng acid dito. Gamitin natin yung bago nating friend na equation. Si VT minus VTEP. Volume titrant, 26. Si VTEP, kulay orange, 25. Times 0.1 si titrant. All divided by volume analyte, volume titrant. So, 50, 26. Okay? Negative log natin. Negative log 26 minus 25. Actually, pwede nyo na ilagay yung 1 na lang. Okay? Times 0.1 divided by 50, 26 equal 288. Okay? Ayan. Take note, may kinorek tayo. So, thank you for noticing that. Yan. So, yan. As you can see, hin-highlight ko na red yung pH at equivalence point. So, that means true yung ating intuition kanina that the pH at equivalence point is acidic, no? Because of the presence of the conjugate acid. Okay? Ito yung sagot, no? Ayan. Ayan. 9.39 nga in tinype ko doon. Okay. Okay, so yan. So tama yung sagot natin. Ayan, 4 points yan. Ang daming ginawa, no? 1 point lang. Ganun talaga, wala tayong magagawa. Okay, so yan ang ating mga sagot. Okay, hopefully nag-gets ha. Pag may question, sabihin ng question. Ito, assignment na lang din uli yan para may practice kayo. And again, magbibigay pa ako ng more exercises para perfect nyo yung ating assignments, yung ating quizzes. Next week ako magbibigay ng quiz. 2 yung quiz, no? So, yan. Good luck. 2 attempts naman. Nasabi ko na yan sa inyo, di ba? 2 attempts, no? Para makabawi talaga. Ay mga mabababa scores, no? Mabababa grades. Kaya nyo na i-8 na. Kasi 2 attempts na eh. Okay? Huwag kayo magkukopyahan, syempre. Ngayon, let's talk about the acid-base indicators. No, I think this was given na sa inyong lecture, pero di-discuss ko pa rin para mas maraming details kayo. Para mas maraming idea. Okay? So again, indicators indicate what? Kaya nga indicators tawag sa kanila. It indicates what? The endpoint, no? So it tells us na endpoint na or malapit na tayo sa equivalence point, no? So these are organic molecules, no? Organic molecules, that means it is composed of carbon, hydrogen, and other atoms, no? Okay? So yan. So these are organic molecules that when subjected to different pH, nagbabago yung color. Okay? Siguro you may ask, no? Paano nangyayari yon, sir? Okay. Pasadahan ko na lang kayo ng idea kasi madidiscuss natin to sa spectrophotometry. No? Ang reason why nagbabago yung kulay niya has something to do with the electrons in the molecule, no? At different pH, no, the electrons in the molecule are disrupted, no? Nagbabago-bago yung position ng electrons sa molecule. And in quantum mechanics, biglang ganun, no? In quantum mechanics, we know that yung electrons, when they are treated with Schrödinger equation, particle in a box, no? Ayan, pwede mo makuha yung corresponding wavelength to the energy of the electrons in the system. Okay. Okay. And the wavelength corresponds to colors. Okay. So yun. So yun yung reason bakit ang daming kulay sa paligid, no? Bakit yung halaman kulay green, yung electrons yung dahilan, ba't ganun? Okay? Yung electrons may energy yon, and that is equivalent to some sort of wavelength which is equivalent to a color. Ganun din dito. Because of the disruption of the pH, no? Because of these different pH conditions, Doon lumalabas ang kanyang true colors. Okay? Pag BS Chem kayo, solve nyo yan. No? Pero ano lang tayo, idea lang. Okay? So basta yung idea, electrons yung dahilan, ba't nagbabago yung mga kulay nila? Okay? So these are some of the common indicators we use in the acid-base titration. Glycerin yellow, phenolphthalein, bromothymol, bromocresol, green or BCG, hindi siya BGC ha. Baka sagot nyo, Bonifacio Global City, methyl orange. And ito yung mga corresponding pH range nila, and these are the colors from acid to base transition. For strong acid, strong base titration, weak acid, strong base titration, SASB, SBSA, and WASB, phenolphthalein gamit natin. Okay, common ang phenolphthalein. Okay, kaya nga ito yung madalas na dinedemo sa lab kasi siya talaga yung ginagamit. Kapag ano naman, kapag weak base, strong acid, ang gamit ay bromocresol green. Or pwede rin naman ito. Okay, so pwedeng either of those three. Ang tanong, bakit? Bakit kaya yun yung ginagamit? Okay? Yung sunod natin tanong, bakit yun yung ginagamit mo, sir? Kasi, di ba kanina, if you could still recall, nasa-solve natin yung pH at endpoint. Sa acid-base titration, ano yung pH at endpoint? 7. Yung 8, medyo malapit lang yun sa 7. Kaya phenolphthalein gamit. Okay? Mamaya pakita ko kung bakit talaga ito yung ginagamit. Kahit 7 yung endpoint nito. Pakita ko kung bakit mamaya. Okay? So, yan. For example, yung weak acid strong base natin, yung acetic acid, ano sagot doon? 8.72. Pasok na pasok yun sa phenolphthalein, di ba? So, ibig sabihin, kailangan the pH at the endpoint should be within the range of the color transition ng indicator natin. Okay? Para ma-observe mo, syempre. Mare, the endpoint is at 3, tapos ginamit mo yung phenolphthalein, wala kang ma-observe. Okay? So, ibig sabihin, gumamit ng indicator that is within the range of, mali yung sentence ko. Gumamit ng indicator wherein yung pH at equivalent point ay pasok sa pH range niya. Okay? Kunwari, yung kanina nga, 8.72, pasok siya dito. Dito gamitin mo. For SASB, SBSA, kahit 7 yan, ang ginagamit pa rin madalas, phenolphthalein. Okay? Explain natin mamaya kasi may graph pa tayo mamaya na. Okay? So, explain natin mamaya bakit ganon kahit 8 to. No? Okay? Pwede rin naman bromothymol blue. Pero the common one is phenolphthalein kasi colorless to pink. Okay? Mas clean yung transition dito. Okay? Kapag WBSA naman, weak base strong acid, sabi natin, ang pH ng endpoint ay less than 7. So you must choose an indicator that changes color below at those pH ranges, no. Basta below 7 yung pH range niya, pwede 'yon. Anong sagot doon? Pwedeng BTB, BCG, MO. Okay? So yan. Ang pinaka-common talaga is the bromocresol green. Okay? Pag yung sulfuric acid, no, hindi. Mali na sa isip ko. Pero alam ko may ginamit namin to dati, methyl orange. Ayun, sa carbonate pala yon. Okay, sa carbonate, kasi naubusan kami neto eh. Ito na lang ginamit namin, methyl orange. No? Kita pa rin naman yung transition. Okay. So, yun lang yung idea. No? Basta kailangan ang pH at equivalence point pasok dun sa pH ranges niya. Okay? So again, when adding indicators, sabi dito, 3 to 5 drops lang. Hindi isang bungkos yung ilalagay mo. Bakit? Kasi when you add too much liquids, what will happen? Madidilute masyado yung analyte mo. Okay? Magbabago yung concentration readings mo. Okay. Ibig sabihin, mali yun. Sagot mo na. Okay. So, kailangan isang patak lang. Patak-patak lang. Okay? Ako ginagawa ko 3 patak lang eh. 1, 2, 3. Tas okay na. Makulay na yon. Okay? So it seems na hindi, pero sobrang kulay na nun. Okay. So these are the other indicators. Papansin nyo, ang dami, no? Okay. So ang mga nagamit ko sa undergraduate ko, itong crystal violet, thymol blue, nagamit ko na yan. Methyl orange, BCG, methyl red, EBT, yan. Phenol red, phenolphthalein, ayun, yun yung mga nagamit ko. Pero papansin nyo, ang daming options na. There are wide variety of indicators to be used. Kahit ano naman, pwede mo gamitin as long as the pH at equivalence point must be within the color transition range nitong indicator. Okay? Kasi baka mamaya yung pH transition mo andito, tas ang pinili mo ito, wala kang ma-observe, no? Kunwari, andito yung pH transition mo, ito pinili mo, wala kang mapapansin. Okay? So, kailangan kung ano yung pipiliin mo, kunwari, ito yung pH, endpoint, kailangan yung mga tatama doon, yung piliin mong indicators. Okay? So, ganun. Kunwari, pH 4 ang endpoint. O, ayan o. Ayan o. Okay. Gamitin mo tong tatlong to. Kasi sila yung tatama doon. Gets natin? Ayan. There are also other considerations, no, na kailangan natin malaman when choosing indicators. No? So in this graph, yung solid curve is the titration curve of 0.5 molar acid. Okay? So 0.5 molar is a very high, very high yung niyan. Very high yung concentration niyan. And yung dashed line, yun yung 0.0005 molar. Masyadong mababa concentration. Ano yung naging effect ng concentration sa graph natin? Yung solid, ito yung 0.05. Itong dash yung 0.0005. Ano napansin nyo? Ang napansin natin is, for high concentrations, the inflection point is mahaba. Okay, mahaba ang inflection point. But at low concentrations, the inflection point becomes shorter. Okay? Ano yung point ko dito? Ganito. Pag strong acid, strong base, since mahaba ang inflection point niya, you can use iba't ibang indicators, no? So, kunwari phenolphthalein, 'di ba? Ito yung endpoint noon, 7. Okay. Slowly, magi-increase 'yon para mag-color change sa phenolphthalein, no? Pasok pa rin naman sa endpoint volume no? So, pasok naman yung yung inflection curve dun sa 25 ml pa rin, no? So, ibig sabihin, you can really use phenolphthalein. Okay, yun, mahaba kasi yung inflection point ng strong acid, strong base, no? Okay? So yun, pag mahaba ang inflection point, okay, pwede mo gamitin talaga yung phenolphthalein. And other indicators can be used as well. For example, bromothymol and the bromocresol. Okay. Any of those, pero wag nyo pagsama-samahin yan kasi magiging rainbow yan, no? Hindi. Wala magugulo yung colors nyo. Okay? So yan. As the stronger the acid, no, or the higher the concentration the acid, the longer the inflection point. That means mas marami kang option to choose from, no, yung indicators. Pero kapag mababa yung concentration ng acid mo, look at what happens, lumiliit yung inflection point na. Ayan na lang siya. So as a result, limited na lang option mo. Hindi mo na pwede gamitin yung BCG. Bakit? Ang inflection point ay lagpas na sa BCG. So wala kang ma-observe na transition dito. So kailangan gumamit ka ng pasok dito sa curve na to. Bromothymol blue lang yung pwede. Yung phenolphthalein hindi eh. Kasi pagdating dito, post-equivalence na yun eh. Okay? So, ibig sabihin, the weaker the acid, no, the shorter the inflection point. That means, mas onti yung options mo. Okay, mas onti yung options mo na indicator. But for strong acids, mahaba yung kanilang inflection point, so pwede ka gumamit ng multiple indicators, no? Okay. Pero again, one at a time lang yan. Hindi mo sila paghahaluin lahat. No? Magulat ka, may rainbow na lang na lumabas dyan, no? So sobrang colorful niya. No? Okay. So yan. Ganon din dito for weak acids. No? So ganito. Sabi natin kapag weak acid titration, weak acid strong base, the endpoint is on the basic side. So greater than 7 yon. So kailangan gumamit ka ng indicator na tatama doon sa mga pH na yon. Okay. So ito yon. So yung papansin nyo, yung bromocresol green, hindi niya natatamaan yung inflection point. So ibig sabihin, useless to. Huwag mo gagamitin yung BCG kasi acidic lang siya ginagamit, no? Eh, ang endpoint natin basic. So, wag ka gagamit BCG. Wala kang ma-observe doon. So, instead, use phenolphthalein or the bromothymol blue. But the better option is the phenolphthalein. Okay. So, again, yung solid line, ito yung strong, ito yung high concentration ng weak acid. And yung dash line, ito yung weak concentration ng weak acid. No? Mababa yung concentration ng weak acid pag dashed. Kapag kapag solid line, mataas yung concentration ng weak acid. So kapag bumababa din yung concentration, lumiliit yung inflection point, that means mas magiging limited yung option mo, no? Okay? Mapapansin nyo dito sa B, nung lumiit yung concentration ng weak acid, medyo hindi na maganda gamitin phenolphthalein. Bromothymol blue na lang gamitin mo. Okay? Or other indicators. No? Okay? So basta yun yung idea. The lower the concentration of the acid, the shorter the inflection point. No? And also, you should keep in mind na ang indicator na pipiliin ay dapat tumama sa equivalence point pH. No? So, for example, bromocresol, hindi yan pwede. X yan. Wala kang ma-observe dyan. Gamit ka nito. Mga nasa basic. Gets yan? Also, the Ka plays role in the length of the inflection curve. No? Okay? The higher the Ka, the longer the inflection point. No? Parang yun pa rin yung idea. The stronger the acid, the longer the inflection point. The higher the Ka, the longer the inflection point. No? So, mapansin nyo, ito ay different curves at different Kas. No? At pag bumababa lalo yung Ka, mas lalong lumiliit yung inflection point. No? Ang pangit lang dun sa mga yun is kapag lumiliit yung inflection point, umuunti yung options mo sa indicator. Okay? Dito pwede ka na gumamit dito ng alizarin yellow. Pwede yan alizarin yellow dito. Okay? Pero itong mga ibang to, pwede ka gumamit ng phenolphthalein. Okay? Pwede ka dito naman, pag tumama dito, pwede yung bromothymol. Pag tumama dito, pwede yung bromocresol. Okay? So, ayan. So, hindi lang tayo limited sa isang indicator, no? Maraming pwede gamitin, no? Depending on the characteristic of your analytes, no? Ganun din kapag weak base, no? Pag weak base, ganun din, the higher the Kb, the stronger the basicity, therefore the longer the inflection point, no? Pag mababa yung Kb, lumiliit yung inflection point. Ibig sabihin nun, hindi mo ma-observe masyado yung transition. Yan. Okay, so ngayon naman, itong polyprotic, this refers to titration na more than one hydrogen ang kailangan, no, para maging balance, para maging complete ang reaction. So either siya ay polyprotic acid, ibig sabihin more than one hydrogen ang kaya i-donate, or pwede rin polyprotic base, ibig sabihin nun more than one hydrogen ang kaya niya tanggapin. Okay? So ano yung mga example noon? We have the diprotic acids and bases, no? Example is the sulfuric acid, H2SO4. it can give off 2H. So, ibig sabihin siya ay diprotic acid. Carbonate, CO3 minus 2, that is a diprotic base, no? Ibig sabihin, it needs 2 hydrogens para ma-neutralize siya. Okay? So, for triprotics, ang common example dyan is the phosphoric acid, H3PO4. It can give off 3 hydrogens. Okay? Para siya ay maging neutral. Wala akong alam na ano eh. Hindi ako masyado familiar sa mga triprotic bases. Pero alam ko meron, no? Pero hindi na namin ine-explore yan. Kasi ang focus talaga is the monoprotics, no? Okay? So ito, nakwentuhan ko na to slightly last time. Pero tignan uli natin to in a newer angle. Okay? So sabi ko sa inyo, ito nga, no? Itong mga long noodles na yan, mga ano na yan, mga mahabang ano, S-shape na yan. Yan yung mga inflection point, no? So itong inflection point, ano napapansin nyo? Mas mahaba to kaysa dito. Bakit? Kasi mas mababa Ka neto. Ito mataas Ka yan eh. Okay? Gets? Bakit naging ganon? Ayan. Kasi the first dissociation is always greater than the second dissociation. Okay. Kaya ito long ang kanyang curve. Ito shorter ang curve. Suppose I want to observe this. No? Wala, gusto ko i-observe ito. Ang pwede ko gamitin na indicators ay, kunwari, ano na lang, bromothymol blue. Okay, o kaya bromocresol green. Okay, pwede yan. Kunwari ito, gusto ko to observe, pwede ako gumamit ng alizarin yellow. Parang yun lang yung idea. No? Okay, so if you want to observe different endpoints, no, you have to use iba't ibang indicators. Okay, what else, no? Sabi ko sa inyo, kung ito yung VTEP, no, meron din VTEP doon, no? Dalawa yung endpoint kapag diprotics, di ba? Nakwento ko ata yun last time. VTEP 1, VTEP 2. The amount of titrant needed to reach VTEP 1 is equal to the amount of the titrant needed to reach the VTEP 2. Okay? So, equal lang sila. Kunwari ito, 10 ml to, papunta sa VTEP 1. O ilang ml uli para makapunta sa VTEP 2? 10 ml uli. Okay? So, equal lang sila. Okay? O kunwari, ito naman ay, let's say, 5 ml. Ito, another 5 ml uli. Okay? So, ganun yung idea. Isa pa. Kunwari, ito ay 13 ml. So, to reach the VTEP 2, mag-add ka uli ng 13 ml. Okay? Or total of 26 ml. Okay? So, yun yung mga characteristic ng diprotic acid curve. Okay? So, the volume of the titrant needed to reach the endpoint 1 is the same volume to reach the second endpoint. Okay? Ano pa? Halfway dyan sa endpoints, makikita mo yung pKa1 and dito naman pKa2. Halfway, papunta dun sa endpoints yung pKa, makikita. Okay? Yan yung na-observe nyo kanina. Kayo mismo naka-observe lang, di ba? Okay, so yan. Important tong pointers na to sinasabi ko, kaya paulit-ulit ha. Yan. Kasi gagamitin natin to sa last topic. Okay, next. Ayan yung mga equation. Mapapansin nyo, ang dami, no? Ito, buffer yan. Buffer yan. So you have the presence of the conjugate base and acid pair. Okay? So you have two buffer systems. Okay? And you have two endpoints. So ibig sabihin, dalawa yung inflection point. And yan yung mga equation na gagamitin. Yan ay derived from the equilibrium calculation. Okay? However, hindi na natin gagamitin siya, no? Okay. Okay na yung monoprotic. Siguro kung sa worksheet, siguro magbibigay na lang ako ng ilang example, no? For siguro mga isa or dalawang example na lang sa diprotic, no? Okay. So ito rin yung equation na gagamitin ko doon, no? Pero ano na lang, dalawang example na lang. Again, ang focus natin is the monoprotic, no? Yung kasi yung pinaka kailangan magets talaga. Itong diprotic, in-extend lang naman to. Okay? This is just extended version. Ayan. Again, ito yung mga pointers, ha. Yan. Kung gaano karaming volume papunta dito, ganun din papunta sa second endpoint. Halfway, andun yung mga pKa's mo. And again, lumiliit ang inflection point as the Ka decreases. Triprotic acid. Ito medyo hindi ko naayos yung curve, no. This should be longer than this. Okay, dapat ito longer than this. And ito, yan, tama yon, maliit lang yan. Okay. So we have 3 inflection points, ibig sabihin 3 endpoints, VTEP1, VTEP2, and si VTEP3. So kung 5 ml to, 5 ml din to reach this one, and another 5 ml to reach that. Okay? So equal pa rin, katulad ng sa diprotic. If nawala na ako. If it required 15 ml to reach this, ilang ml how to reach this ulit? 15 na naman. Then another 15, dagdag ka ulit ng 15, so 45 ml na yon, ma-reach mo na yung last endpoint. Okay? So ganun lang yung idea. Kung gaano karami pupunta sa first endpoint, ganun din papunta sa second endpoint, and to the third endpoint, ganun din. And then again, halfway, papunta sa mga endpoints, makikita mo yung mga pKa's na. And yun nga, the more Ka's, the shorter the inflection point becomes. No? Katulad ng sinabi ko sa kaninang slides. Okay? Ang ingay ng upuan ko. Ayan. So, ayan yung sandamukal na equation na gagamitin. Hindi ko na kayo bibigyan ng triprotic, no? Hindi ko naman ito masyado na-encounter, eh. Wala nga ganito ng boards, eh. Okay, kaya hindi ko na kayo bibigyan ng triprotic. But again, lahat ng yan ay dinerive from equilibrium. Okay? Dinerive yan lahat from equilibrium. Dami, no? Yan. Kaya nga sabi ko sa inyo, pag BS Chem, hindi ka magkakabisado ng equations, eh. Yung ano na lang kakabisaduhin mo, equilibrium. Tapos ikaw na bahala mag-derive. Kaya pag di mo ma-derive, iyak ka na lang. Dumating yung mga ganong time sa buhay ko. Parang nakatulala ka na lang. Di mo alam kung ano na nangyayari. Okay. So ito, diprotic base naman. Ganun pa rin. Reverse lang ng diprotic acid. Okay. So you have 2 endpoints. Ang example na ito ay carbonates. Yan, i-emphasize ko to kasi ito yung di-discuss natin next time. Carbonates na. Ayan. So again, dalawa VTEP niya. VTEP1, VTEP2. So if this required 5 ml, yun ay 5 ml. Okay. Ano to? 50 ml, another 15 ml. Okay, so 30 ml in total. Okay. And then halfway, makikita mo yung pKb's. pKb1, pKb2. And for each inflection point, take note, you need to use different indicators. Kunwari dito, gamitin mo phenolphthalein. Dito, you can use the bromocresol green. Okay? Kung gusto mo ma-observe yan, lagay ka PHP. Pag naging colorless na yung PHP, maglagay ka naman BCG to observe this. Okay? So, ganun yung ginagawa namin. And these are the equations derived from the equilibrium. Hindi ko na masyado ibibigyan to ng focus. No? Doon tayo sa monoprotics magfo-focus kasi talaga. Ayan, we're done. Bakit ko in-emphasize yung mga ilang idea na yon about sa kung ilan yung BTEP, Kung ilan yung volume to reach the VTEP 1, ganun din to reach the VTEP 2. I-apply kasi natin yun dito sa titration of acid-base mixture. No? Ayan. So, ito yung isang example doon. Kunwari, carbonate meron ka. O, yung first titration mo, transition ng phenolphthalein. Pag naging colorless na yon, ibig sabihin, okay na yung reaction. Papunta ka na sa pangalawang transition. Ganyan. Okay. Now, next meeting ko to gagawin, ha? Okay. And yun, again, take note that you should use the indicator that is within the range of the inflection point. For example, ito sa BCG, ay sa sodium bicarbonate. Ang inflection point niya ay nasa acidic part, no? So, wag ka gagamit ng PHP. BCG lang. Kasi dun siya magta-transition eh. Kita nyo yon? Ayun. Okay. So, yun. No? Next meeting na lang to ha. Okay. Discuss ko rin to next meeting para maraming ganap tayo. Okay, so with that, I hope you learned something. Okay, again, it is very important for you to understand bakit ganun yung equations natin. Bakit nga ba? Because they are all derived from equilibrium. Doon lang siya dinerive lahat. Okay, so hopefully you understand the equilibrium very well. Okay, ang tagal natin din-discuss yun. Kaya kailangan gets yun. Ha? Okay, so yun. Kasi yun lang naman talaga yung basis ng equations natin dito. Okay? So, do you have any question about our session? Or okay na tayo? Ay, yung assignments nyo ha. Upload ko na lang answer sa Canvas by weekend. No? So, sa weekend ko na gagawin. Most likely Sunday. No? Kasi natutulog ako pag Sabado. So, yan. Sir, kasama po sa quiz yung Diprotic. Siguro hindi na, no? Although magbibigay lang ako ng example ng Diprotic sa worksheet, no? Kasi yung final exam, naka-shuffle madalas yun, di ba? Yung exam kasi ninyo, ang nangyayari doon, no? Minsan medyo fair siya, minsan medyo unfair, no? May mga students na yung set of questions sa kanila ay madadali. Merong set of students na yung dumating na question sila, yung mga question na binibigay ko, may hirap. Okay. So, yun yung problema. No? Pag puro may hirap yung question na lumabas sa'yo, GG ka talaga. No? Yung score mo, mababa. Okay. Unless kinaya mo talaga. No? Kaya, yun. Again, test banking kasi mangyayari sa atin sa final exam. Okay. Ako, magbibigay na lang ako ng ilang activities for the Diprotic. Pero hindi masyado. No? So, I will let my peers know na bawasan yung Diprotic. Anyway, ako naman yung nagko-compile. Ako kasi nagko-compile ng questions sa quiz, sa exam. Okay. Mamomonitor ko yung mga questionnaires. Pero again, expect na baka may lumabas na ganun, pero onting items lang. Kaya onti lang din yung ibibigay kong sample. Mag-focus tayo on the monoprotics. No? Ayan. Sila yung pinaka-puso ng titration talaga. Okay. So magbibigay ako pero onti. Sa quiz, siguro isang item lang. Okay, isang item lang talaga. Okay. Ayan ha. So ako i-monitor ko yung mga magiging questions sa final exam kasi ako yung nagko-compile eh. Okay. So yan okay. Basta yan yung calculation natin. Wag kayo masanay sa sundin ko na lang to kasi yan yung nakalagay. Wag ganun ha. Dapat alam nyo yung underlying concept. Okay. Kasi makakalimutan nyo yun eh. Nag face-to-face tayo. Kalimutan yun na. Tapos may qualifying exam pala kayo, no? Share ko lang. May battery exam kayo pag bago kayo mag-third year. Okay. So, doon malalaman kung mag-stay or go ka na. No? So, kasama na yung chemistry sa qualifying exam, no? So, we were asked, about that, no? So, yun. Ibig sabihin, kailangan nyo talaga sa seryosohin, no? So, yung Anachem is not just a subject na kailangan lang ipasa, but a subject needs to be understood. No? Kasama na siya sa QE or sa battery. Good luck. Alam ko papasa kayo. Okay. So, yan. Laban lang. Ayun, wala na akong masabi. Okay. So, ano yan, kain na muna kayo, no? So, if you have any other concerns, no, don't hesitate to message me. I will try to reply on time. Although ngayon, medyo naging busy na yung schedule ko because puno na uli yung class schedule ko. Monday to Saturday na ako nagtuturo uli. Then I have my grad school, no, sa gabi. Kaya ayun, GG, no. Onti lang pahinga ko. Okay. So basta yan, pero I will try to attend to your needs, no. Okay? Kasi para matuto kayo. Okay? So with that, no, so thank you for attending. Always stay safe, no. Mag-ingat paglalabas. Kung hindi naman kailangan lumabas, sa bahay na lang, no. Kung kaya magpa-grab, mag-grab na lang, no. Okay. Pero kung kailangan lumabas, di ingat, ha. Okay? Gumamit ng face mask, no. Yung face shield, wala naman silbi yun eh. Okay. Basta mag-ingat, ha. Ayun. So, I'll stop the recording and I'll see you again next time. Bye-bye and kain na po ng lunch. Bye-bye.